Hello, I'm Tom Walski, representing the Environmental and Water Resource Institute Water Distribution System Analysis History Project. This project is to document the history of water distribution system analysis. An important part of the project is a series of interviews with important engineers, modelers, researchers, and practitioners who have made significant contributions to the field of water distribution system analysis. Our interview today is with Dr. Lindell Ormsbee. Lindell's a professor at the University of Kentucky and has been active in the area of water distribution system analysis for the past 35 years. The interview is being conducted on May 16, 2015 in Austin, Texas. So Lindell, when did you really get interested in water distribution system analysis?
Well, I think actually, like a lot of engineering students, I kind of knew I wanted to be an engineer when I was real young, but when I went to civil engineering, I was probably thinking more like structures engineering. I think that's what a lot of incoming engineers think about. And then I took a couple of classes, and one in particular with Don Wood, that kind of introduced me to fluid dynamics and looking at water distribution systems, and I was kind of hooked from that point on, I think.
So how did that carry over into your master's thesis work at Virginia Tech?
Great question. So I took this really cool design course with Don my senior year, and then decided to go and pursue a master's degree at Virginia Tech, and went down there, and my advisor was really a guy by the name of Denshaw Contractor, who was really more of a groundwater person, but I still had this interest in water distribution systems. So I kind of embarked on a project to look at optimizing the design of water distribution systems. There had been a little bit of work in that area prior to that, but not a whole lot with regard to really applications. So I actually wrote a code for my own analysis program, and then used an optimization method that I found in a journal back in the 60s that I thought worked pretty well. Adapted that, and then developed my thesis on that basis. So that was kind of the inspiration for my master's thesis, was some of the work I did with Don Wood. So.
Well, you have a broad background in hydrology, water resources, environmental quality, related fields, yet you've found some way to also do water distribution work as well. Now, what percentage of your work is water distribution, and how do you ever find the time?
Well, when I started out, after I got my doctorate, I actually got my doctorate at Purdue, and then went back to UK. There was an opening, and so I went back on faculty there, and so I really got to work very closely with Don Wood, and that really kind of influenced a lot of my initial research. Probably the first probably 10 years or so, I kind of focused on water distribution applications, looking at design, calibration issues, moved into some operational problems, looked at water quality and so on. And then probably in the middle of my career, I kind of then moved into a lot of other areas like you mentioned. Did a lot of work with Department of Energy, looking at some very large facilities. And then over the last several years, probably the last 5 years, I've been able to kind of get back into the distribution field, partly as a result of some work with Homeland Security, looking at infrastructure security and so on. So that's one of the things I love about my job, is I can always pursue new areas, and I typically don't stay in one area. I'm always looking for the next new area to kind of pique my interest with.
First time I ran into you was at the first Battle of the Network Models in the early 80s. You didn't have the least cost solution, but in my opinion, you had one of the best because it was more realistic and the kind of thing that engineers would do. Tell us about that experience.
Well, I think part of that was helped a little bit because after I got my master's, I worked for a consulting engineering firm for a couple years and actually helped design some systems sort of in real life. And so when we were given that problem, I was trying to kind of draw back on some of my experiences at what are some practical things that you could do in a system, what things are really not practical. Knowing, for example, just as a trivial example, that when you size pipes in a pipe distribution system, there's no such thing as a continuous diameter. There are predetermined nominal diameters that you have to work with, and so just drawing on some of those experiences, I tried to incorporate that into kind of my design. I did have that optimizer that I developed for my master's thesis that I adapted for that project, but tried to integrate some of these more practical concerns and considerations into the problem. I still remember that conference. That was really the first time I had ever really presented anything and there was about, I think, probably about 8 to 10 people participating. It was incredibly intimidating. I was going up against some of these people that I'd read in the literature for years, and I was pretty nervous, I remember, when I made my presentation. But I do remember Downey Brill was there, and he was making a presentation with his group, and he kind of came along and was real supportive, kind of calmed me down, and I was able to get through with that. But I still remember that presentation. So.
Well, then we worked on pumping optimization in Washington, D.C. in that area. To this date, no one's really come up with anything that's that much better than the things that we did way back then. What are your thoughts about this whole idea of pumping optimization?
Well, that was a fantastic project, and that was just great getting to work together with you, Tom, on such a complicated system, the Washington, D.C. system, and then also the federal aid and water main system. I think probably one of the challenges in a lot of those technologies is sometimes the algorithms and technologies are kind of developed in a vacuum, not working with an actual real-world system. And I think the real world always is not exactly how you envision it theoretically. There's always things you have to work around with. So in some cases, I think maybe part of the reasons why some of the technologies have not been implemented quite as readily is that you have a lot of practical issues you have to kind of factor in, and it's really hard to take an algorithm just off the shelf and make it work in every case. You typically have to adapt to the particular problems that you're working with. You have to rely on the data. I remember, for example, in that situation, we had 2 different utilities, in essence, that were kind of working together, and we were relying on some of their data. I remember some of our initial calibrations, we kept backing into some values that did not seem to fit, and what we ultimately found was some of the people recording the data were essentially just making up the data every hour and recording them on a time chart, and we were using that data. But that was a fascinating example, though, of how doing some modeling, we were able to kind of ferret out or figure out that there were some inaccuracies actually in the data. So a lot of times you have to work with data that's not perfect, that's noisy, and you have to have algorithms that accommodate that. And sometimes algorithms are not designed to really be able to do that. So I think those are some of the challenges that you have to look at when you're trying to apply some of those types of technologies.
You also worked on water distribution system reliability, and there's example studies around the Pentagon and other key buildings in D.C. I have a picture of you opening up a fire hydrant as part of that work near National Airport. I bet you don't get to do much field work anymore in your current position, or do you still get out?
I get a little bit. I've kind of moved more into research administration now, but we did with our Homeland Security project we recently completed. We actually got out and worked with several utilities and did some field work with that, and it's always invaluable to actually be able to go out and look at what you're dealing with if you're trying to model it. You really can't just rely on some theoretical conceptualization of that. That project was fascinating, just some of the stories, as you know, doing fire flow tests on the Pentagon grounds and the security issues. And this was before 9/11, as you recall. And then, we discovered that National Airport actually only had 1 6-inch line connecting to it that was operational at the time. If you recall, they had some other lines that were basically crushed and closed. And so that was really a fascinating study. Also, just the history we learned about the system, I thought was really great.
Yeah, if we tried to do that today, they probably would have shot us.
Yeah, probably so. We would have gotten close to the building, as I recall.
You've also done some nice presentations on hydraulics history, which fits really well with this project. What motivated your interest in history?
I think part of it was probably when I was a child. I actually lived for 3 years in Panama. My dad was in the military, and so we lived in the Canal Zone, and I really got exposed to just some of the incredible engineering works that folks did back at the turn of the century. And that really got me interested really in the history of engineering and water projects and so on. So I've always kind of had a strong interest in history, and it's always fascinated me to go back and better understand how people actually developed algorithms and what they were thinking and what some of the challenges that they faced. Looking at some of the algorithms that were developed or methods that were developed back in the the 20s and 30s, really before they even had digital computers, that people came up with ways to tackle some of these water distribution problems. It's really fascinating. It's just amazing how brilliant some of these people were.
You've also been involved with commercial software business with Dr. Wood and Dr. Lingredi. How has that evolved over the years, and how has competition with EPANET affected that?
Well, that could take probably several hours to get into some of the discussions and the stories. As you know, back in the old days, it was very easy for anyone kind of to write some code and put it out there in a disk, especially back in the DOS days where you didn't have to worry about computer graphics and so on. And so I was really fortunate to be able to be working with Don at really the beginning of that whole commercialization process, and kind of see how KY pipe evolved over time. So, but relative to some of the other algorithms, as you remember, we had a couple of AWDSA conferences and ASCE conferences. We'd have probably 10 to 12 people that were trying to develop and commercialize software, and just over time, a lot of those just kind of dropped off, and so there were just sort of a handful that were left. And in some sense, I think everybody knew each other, and actually it worked together in many cases. So it is somewhat of a pretty small family these days with regard to probably the four major pieces of software that are running out there. Yeah, I think at the beginning days, there was a company called Stoner and Associates that had some commercial software that they were selling, and they actually had a computer. You could actually send your systems to them, and they would run the initial analysis. Really, Don Wood got into starting to market KY pipe about, I think, 1972, about that period, and we just had some short courses that we would teach at the university. The code at that time was run on a mainframe, so it really wasn't used by a lot of folks. I think kind of the breakthrough came when the microcomputers started to come onto the scene, and so we were able to start putting the program on old 5 1/4 floppy disks that you could send out and people could start using. And about the same time, you had John Hasted was developing some interfaces with software, and actually most people may not know this, John and Don actually collaborated together in the early days, and some of the early software that Hasted was using or marketing was actually using KY Pipe's engine for part of the time. And then you had some of the other algorithms. The EPA development's an interesting story. I think some of the folks at EPA were looking to develop an algorithm for doing water quality analysis, and they were looking for a hydraulic engine at the time. And unbeknownst to me, I think Bob Clark had sent Don an email, or not an email, they didn't, this is before emails, sent him a letter about maybe doing some collaboration, and Don, I think, just took the letter and put it in his inbox, was going to get to it later, and Don was always focusing on the algorithm and dealing with customers, so he really didn't really follow up on that, and I think EPA just said, well, maybe they're not interested, and so as a consequence, Lou Rossman, I think, got involved and actually wrote their own hydraulic code, which obviously served as the basis of EPANet. So it's potentially fascinating story. If Don maybe had responded to that letter at the time, EPANet may never have existed, or at least not in its current form. So that's a sort of an interesting story. But relative to sort of the competition, I think there was some concern by some of the companies at the time that were in the commercial market, such as Hasted Methods, maybe Stoner, and to lesser degree probably Don, about maybe an unfair competition with EPANet since it was being backed by the government. Of course, a lot of these guys were out there selling software, although UK was still, or the KY Pipe program was still affiliated with the University of Kentucky and was kind of being sold through a university center. So a lot of the income was actually going to the university as well. But my recollection was there was some several meetings, maybe with some congressional folks involved or something. I was not directly involved in all those deliberations, but anyway, I think there were some common agreements that kind of came out of that about who would be doing what and so on. And I think potentially partly out of a result of that, KY Pipe actually then basically broke away from the university about 2000 and went out as a separate company. So that's a little bit about the history. There's a lot of other stories I could tell, but we don't probably have time for all that.
I know at the beginning of your career you were very involved with AWWA. How did that relationship impact your research?
Well, as you know, we were both very involved, and it's been fascinating to kind of watch the evolution of the research community, I think, over time. Back in the early 80s, there was not a lot of really community, I think, in ASCE at the time related to water distribution analysis. There were a few people. We'd go to conferences. We may have a session or two, but I think a lot of the research folks were really working through the AWWA community at the time, partly because there were a lot of practitioners were involved in industry interactions, and so over time. That's changed somewhat, but at the beginning we were both really involved both in AWWA and in ASCE, and over the years there's been a lot more I think movement and growth in ASCE and now EWRI relative to the whole topic of water distribution analysis. But I think probably in the early days a lot of that work was being done in AWWA. And so, I had probably about a 10-year hiatus somewhat in really getting involved in the research. And so when I came back and started focusing more in that area, it was fascinating to see the explosion of folks that were now involved in distribution analysis, attending the ASCE meetings and so on, partly due to some of the leadership of Jim Huber and putting together the annual track at the ASCE meetings, but and then also the collaborations internationally that arose out of a lot of that as well. I know back in the 80s we had done some collaboration with some of the folks in England, but it's just been fascinating to see the growth of that over time now with folks from India and obviously the folks from Australia and so on. So.
It seems as if the researchers go to ASCE meetings and the practitioners go to AWWA meetings.
It's kind of been that way. Although I think in the earlier days there were more practitioners that went to ASCE meetings, quite frankly. But it's kind of over the years. It seems to me you've kind of seen that migration, which I really think is not necessarily a good thing. I'd like to see more practitioners engaged with the research community and in ASCE. So that's something we've talked about in the past and I'd like to try to help foster perhaps.
Yeah, how have you seen the water distribution system analysis research evolving over the years?
Well, as you know, back in the old days, most people were kind of focusing on analysis codes. We had a lot of space and storage limitations in the computers, so a lot of times you would have algorithms that would be developed just to get around those physical limitations. Now a lot of that's been eliminated, but I've seen a proliferation, a lot of work on optimization applications, and I think sometimes the theory or the theoretical concepts and the algorithms maybe are starting to migrate too far away from reality, and it's good to try to bring those back together. So I guess that's kind of one concern I've seen over the years, is trying to make sure that our algorithms are actually solving real-world problems, not theoretical problems. That's one of the reasons we're involved in some work right now trying to bring real data sets into the research community that they can work with to try to ground truth a lot of their theory. I think as things evolve over time, a lot of times in the past we'd have to build algorithms that were somewhat data deficient, and now there's potentially, as you start looking at real-time modeling, maybe the opposite problem. You've got more data than you know what to do with, and trying to filter out all that data and filter out noise and things of that nature become another whole set of problems that people are looking at. So it is fascinating. I remember back in the 70s, and then early 80s, when the algorithm problem or the analysis problem was basically just about solved. I think a lot of people in the research community thought, well, all the problems in water distribution system analysis have now been completed, so what are we going to do next? And that obviously hasn't been the case. There's been an explosion of other issues. I think certainly the security issue has been a big stimulus to water research and distribution analyses with regard to water quality analysis and so on. I remember when we were initially starting to play around with water quality analysis, the question is, well, this is interesting stuff and it might help improve operations, but is anyone really going to actually do these types of analyses in the future? And certainly after 9/11, that question has been answered in the affirmative.
So as a result of this, though, you've become kind of skeptical of optimization. Do you want to say anything about that?
Well, we've had running debates over the years, as both the two of us and others. As you recall, I think I had a paper published on optimization or optimal calibration, I think, of water distribution systems. This has been back in the 80s. And I got the reviews back. This is when they used to mail your reviews and packets and everything. And I got this one review back from this guy that said, Lindell, how many times have I told you this optimization stuff will never work? Signed, Tom Walski. So to this day, I think that's the only review I ever got back anonymously where the reviewer signed it. But I think there is a potential place for optimization, but I am a little skeptical when sometimes these algorithms are developed in a vacuum without basically being tied to real systems and being developed in that context. I think you've got to have good data to be able to design systems, but invariably, and I think we've seen this a lot of the competitions over the years, the battle of the network models, the battle of the sensor placement models, or whatever. There's always intangibles you can't necessarily build into a mathematical formulation, and you've got to really use some engineering judgment. A lot of that comes from experience, so I think optimization models have a potential use, but I see them more as tools than black box that we throw the problem into and out magically comes a solution.
In your recent project, you developed many test models from systems in Kentucky. It sounds like a really interesting project. You want to highlight some of the benefits of that?
Yeah, that's a good point. What we've been working on is developing a database of actual real systems that can be used by members of the research community to test their algorithms. As you know, it's fascinating. We've got hundreds of papers published on various algorithms, but a lot of them are really based on a handful of systems that are used to test them with. And one of the things we found in developing this database is you can have sort of different types of systems. You can have branch systems, loop systems, and grid systems. And one algorithm that may work fine for one type of system, such as a branch system, may not work that well for a loop or a grid system. And so what we've tried to do is develop a very robust database, so when people are developing algorithms, they can test it on all of these systems to make sure that the algorithms are truly robust. I know the optimization community over the years has done this. They've got about 30 to 40 sort of test example problems that people in that community use to test all their algorithms with. And so we think this type of database for our community would also be very useful.
Well, in your career, you've worked with a lot of engineers and researchers. Which folks in the industry do you think had the greatest impact on your career?
Let's see. Well, I'd probably first start with a guy by the name of Tom Walski. But Tom actually got me involved in some really good practical work in the early 80s, working with the Pentagon, doing some analysis in Washington, D.C., and doing some optimal operation type work, some reliability work. And I think one of the things I learned from Tom was the importance of actually being out in the field, analyzing the system, getting a hands-on perspective of things. And then some of the nomographs that Tom developed I really thought really good, very practical. And just the perspective of trying to solve the real problem, not the problem that you think exists or that you want to exist. So that was certainly someone that had a big influence. And then, of course, Walter Grayman. Got to know him real early in my career, not only in ASCE but AWWA. And again, another person that had a practical perspective on problems. I thought both Tom and Walter had a good mix of practice and theory, which I've kind of tried to follow somewhat in their footsteps in that regard, if I can say that. Some other people that encouraged me, I know down through the years, would be like Downey Brill, who's now at NC State. And Downey, I always see it every year at the ASCE conferences, and was always encouraging me, checking what I was working on. And so I'd have to mention Downey. And then certainly Uri Shamir had a big influence on my career. Uri was someone I really admired a lot and really appreciated his research. Certainly we had some interactions and overlaps in our interests with regard to optimal operations, and so Uri was certainly someone that I really respected a lot, and he also encouraged me a lot in my career. So those are three or four that immediately come to mind. And then I also had an opportunity to really do some work with several people. Kevin Lanzi and I collaborated on some stuff together, and so we've kept up over the years, and then had a little bit of opportunity to interface some with Jim Huber over the years, Lou Rossman with EPA Net. So I mean, I could go on probably for quite a while, but those are ones that just jump out immediately in my memory.
One of the people that you studied with was G.V. Logan Nathan, and what about his impact on your career?
G.V. impacted me not only professionally, but I think personally. We were both suite mates at Purdue when we got our doctorates, and I had got my master's at Virginia Tech, and then G.V. went to Virginia Tech on faculty when I was over at UK, and so we kept up pretty close over the years. Would always see each other during the annual meetings, and as most people know, G.V. also did some work in water distribution analysis, infrastructure analysis, reliability, and so on. But I think what impacted me the most about G.V. was just his love of life, his enthusiasm for research and students, and so that really impacted me, I think, in looking at how I viewed my own career and in my interactions with students. He was certainly someone to emulate in that regard.
Okay. So looking back on your career so far, what do you feel have been your greatest contributions to the field of water distribution system analysis?
Well, I was very fortunate to be kind of in a right place at the right time, somewhat. Being able to collaborate with Don Wood at the outset was just an incredible experience. I got to learn a lot with Don, got to really interface with a lot of industry folks as a result of that. Over the years, I probably taught over 140 short courses all over the country, working with practical engineers, and that really enriched, I think, my research experience, hearing practical problems that people were trying to solve and thinking about, okay, how can we go back and do some research to address that, or write some type of code, or how can we make our software more usable, those types of things. So I think those are things that certainly I appreciated. But relative to contributions, I think I was able to advance some of the area in water distribution analyses. Don and I worked on some methodologies to solve for parameters other than just flows and pressures, as you know. Also did a lot of work in calibration, trying to come up with ways to make systems easier to calibrate, and also looking how to better communicate science to the engineering practice. I think that's something I was able to help potentially promote. And then, you know, we made contributions, I think, a lot of other areas, including operations of water systems, demand forecasting, Did some work in water quality analysis, and more recently looking at security issues, reliability, and so on. So I kind of dabbled in a lot of things. I think that's kind of my nature is after a while, I'm always looking for the new thing or the new wrinkle on something, and so I'm never kind of staying in the same area, always kind of moving around, which is one of the great things about being in an academic community is having the freedom to always pursue your interests. So those are a few things that I was able to contribute to. And the greatest thing is just being able to be in a professional community like ASCE provides and just meet so many fantastic people and really learn from them. Just there's so many brilliant people in our community that do some amazing things, and it's just always exciting every year to come to the conference and find out what people are working on, because I'm always learning something new. So that's what I enjoy about it.
Hey, great, Lindell. Thanks a lot for doing this interview for us on behalf of the History Committee. Really appreciate you taking the time and also just all the contributions you have made to the profession.
Thanks, Tom. Appreciate it.